Okay, good morning, good afternoon, good evening, and welcome to our webinar, Optimizing Cell Culture Conditions, How to Maximize Production with Peristaltic Pump Technology. My name's Joe, I'm your host, and I just want to thank you all for taking time out for what will be another very informative presentation. This webinar is part of a larger series of scientific expert webinars that we host every 3 weeks here at Cole Palmer. There is a link that I've put into the follow-up emails that go straight after this webinar finishes, so please take a look at that when you get a chance. Okay, just before we get started, before I hand you over to our presenters today, I'm just going to run through a few key items just to help you get settled in. So obviously you're on a WebEx platform today, and there's a Q&A panel to the right-hand side. If you want to ask any questions today, please type your questions into that Q&A panel at any time during the presentation. At the end of the presentation, we've got plenty of time put in today just to go through those questions. So I'll be reading the questions out to our team of experts today. And don't worry, if your question doesn't get asked today, what we tend to do is put together a Q&A document. And this Q&A document has every single question that was asked with complete answers to every question. We put it into a nice PDF and we send that out to everyone who's attended today. So please don't worry, but do ask questions. Another thing that I need to point out is that today's presentation features 2 or 3 polls. So during the presentation, there'll be short breaks where we'll ask you a very brief question. If you can just take 5 seconds to review the panel. Again, a panel on the right-hand side called polls. In there, you'll see the question and the list of options on the answers. It's very quick. It's just one click done. So if you don't mind taking a little bit of time, a few seconds, just to do that as we go along, that really helps as well. And at the very, very end, once this presentation is finished, there's also a very short survey. And again, we really appreciate your feedback on what you heard today. It won't take more than 30 seconds to fill that survey out. So please do take some time on that one. Okay, moving on. So who are we? Well, we're Masterflex. We're part of Cole Palmer. I just thought I'd share 3 key statistics with you about Masterflex. So we are a leading innovator in peristaltic pump technology with over 25 patents in fluid handling products. We patented the only peristaltic pump that controls 4 channels independently. It's called the Reglo ICC, so it's a very important and special pump. And we are the only manufacturer with a full suite of peristaltic pumps that has an Ethernet IP and advanced connectivity. So it's a very impressive range of pumps. So that's who we are, but what about our panel of experts? Well, today we've got 3 experts, all from the Masterflex team. We've got Greg Johnson, Phil Nyron, and Mike Knapp on the end there. Collectively, they're all responsible for our fluidics product range on a global scale. And between them, these guys have enough experience spanning almost, I kind of tried to work this out the other day, I think it's about 100 years. So there's quite a lot of energy and experience in there. And there's a good chunk of that dedicated to biopharma. So you're in really good hands here. And I know these guys quite well from working here for a while now. And they are packed with knowledge and know-how. And ultimately, these guys are problem-solving machines. So there's nothing these guys can't figure out. Okay, so just touching on the 3 learning objectives. So today's topic, optimizing cell culture workflow with peristaltic pumps. We'll deal with the mundane part of the process, moving fluids in each step of the workflow and how optimizing these simple fluid systems can help improve the cell culture result and increase yields, which is obviously really important. So in short, how fluid shear impacts cell viability and production costs, how pumping technology can enhance your fermentation yields, and how to incorporate automation to improve productivity. So that's what you're going to get from today. So I hope you're ready for this. I'm now going to hand you over to Greg.
Thank you, Joe, and good morning, good afternoon, good evening. Thank you for taking time out of your schedule today to join in today's discussion. We're going to cover 4 key processes that we found typically make up the cell culture workflow. This is where we're going to focus our time today. Secondly, we're going to review attributes of Peristaltic, specifically Masterflex and Ismatec technology that makes them an ideal fit for cell culture applications. Finally, we're going to review how utilizing this technology will help improve the cell culture workflow. Let's get started. Most cell culture workflows can be broken down into 4 phases. Preparation, where the media and seed culture are prepped and ready to go into their initial stages. The growth or fermentation stage, which is where the culture is expanded and the growth of the seed culture grows. Finally, there's third, there's the harvest stage where the growth phase is discontinued and we're prepared to for the purification phase, for the extraction of the desired element. And then finally, where the final product, usually a protein or nucleic acid from the cell components, and final packaging occurs for further storage or use is completed. So Mike, this is our first conversation starter.
Yeah, thanks, Greg. Now I'd like to take a moment to expand our conversation to include all of you by asking this poll question. Do you use manual processes like pouring or decanting, or do you use liquid handling equipment, pipettes, to do your fluid handling? Do you use pumps, or do you use a combination of all of these? So if you could take like 10 seconds to just answer what fits to you, we'll go ahead and report the results so we can see where everybody's coming from. There, okay, we see the answers coming in. And fantastic. And it looks like the combination is the biggest answer, over 50%, followed by pumps. So thank you very much for pulling that together so we can see where we all stand. And now I'll turn it over to Greg.
So beginning our deep dive reviews, our first step in the cell culture workflow is preparation for it. A critical support process in bioprocessing. Sometimes this process relies on prepackaged or standardized media or preparing cut media blends in-house from ground powders or concentrate. Typically, these will require filtration to purify it before use in the cell culture process. In media preparation, the stew or solution that provides an optimal cell growth environment, peristaltic pumps provide the metering accuracy needed to rehydrate powdered media or dilute concentrate media into custom in-house blends. At the filtration stage of this process, it is simple removal of contaminants that may have been present in the concentrate or media. We will review the filtration application in depth later, but here Masterflex pumps provide both the flow velocity and pressure needed to produce effective filtration results. And lastly, at this stage, storage and transfer. These are self-explanatory as the media needs to be stored or transferred to the next step in the process. Phil, this is where you take over here.
Thanks, Greg. And hopefully everyone can hear me okay. And I will add my thanks to everyone who was able to join today and taking time out from no doubt your busy schedule. So again, thanks for being on the webinar today. But going into the second phase is what we're calling growth or fermentation. Both terms are typically used, but at the heart of the process, at the heart of this phase, fermentation typically creates the target proteins or nucleic acids by multiplying cells from the seed culture that Greg referred to a bit earlier. And typically this phase requires careful monitoring of the environmental conditions, of the conditions within the fermenter or bioreactor, coupled with the precise addition or extraction of media and other additives that are essential to maintain that environment for effective growth. Next slide. So during that growth or fermentation step, there are a number of different sub-processes going on. And kind of getting into a little bit of what goes on with the growth phase as these cells are growing, metabolizing. Oftentimes pH imbalances can be caused by the waste from the growing cells, from the metabolic byproducts. And that pH can be regulated via a pH controller and additives. And this, again, contributes to maintaining that optimal growth environment, and typically involves a sensor of some kind for measuring the pH, and also pumps for adding acid or base or other reagent metering in order to maintain that pH level at the optimal point. Secondly, continued addition of fresh media provides nutrients for cells to grow, and oftentimes nutrient media is being exchanged, withdrawn, or extracted and pumped back in simultaneously, typically at matching flow rates. Maintenance of correct oxygen levels in this environment is also critical. It further ensures the stable environment that's needed to optimize the cell growth cycle as the cells go through their different phases. Peristaltic pumps are able to deliver the accuracy of flow control coupled with the low contamination risk required to deliver these control reagents and then maintain that optimal environment throughout this growth or fermentation cycle. Oftentimes those peristaltic pumps are also used to recirculate the mix to keep cells in suspension and the reactor contents, particularly with bag style or wave type bioreactors. And back to you, Greg.
Thanks, Phil. So the third process we'd like to focus on in the cell culture is the harvest process. From washing to buffer injection to filtering, the sub-steps in the harvesting begin to separate the protein nucleic acids from the cells. Look to peristaltic pumps for fluid transfer capabilities as well as single-use products to connect between filters and vessels. Depending on the production scale, our filtration products may also provide critical performance solutions in your process. We're going to dive deep into two sub-processes within the harvest phase: continuous flow centrifugation and filtration. Continuous flow centrifuge rotors convert the batch centrifuge into a continuous process, allowing for longer campaigns. These specialized rotors need a pump to inject the cell suspension. For this part of the process, these pumps require a programmable flow rate, high purity, low contaminating tubing, and an accurate pump head. Peristaltic pumps provide the low shear to prevent cell damage, and the high purity tubing materials prevent contamination of the product. The second process we want to look at is tangential flow filtration, also known as cross-flow filtration. The majority of the feed in these filters flows or travels tangentially across the surface of the filter rather than across in the filter as with dead-end filtration. The principal advantage of tangential flow filtration is that the filter cake, which oftentimes blinds the filter, is substantially washed away during the filtration process. This increases the length of time that a filter unit can be used, and it can also be used at a continuous process, unlike batch-wise or dead-end type filtration. The trick in tangential flow filtration effectively is to regulate both the transmember pressure and cross-flow flow rate to prevent membrane fouling. This allows a greater volume of product to be processed in the least possible time. Peristaltic pumps are needed in filtration to provide the mechanism to push fluids through the filtration apparatus. Peristaltic technology is uniquely suited to these applications. Fluid touches only the material of the tubing. It can also generate the flow velocity and the higher pressures to improve and lengthen the filtration cycles through the filter. Phil, back to you.
Thanks, Greg. So this takes us to the last step in the process that we're going to be talking about today, and that's the step of purification. And purification is the step that separates the product, the protein, nucleic acid, or other target molecule, from other cell components and contaminants. And the product is then concentrated and refined in preparation for final fill. Next slide. So the pump is generally one of the first things that is encountered by the fluid or suspension in a chromatographic separation. And peristaltic pumps are the most commonly used pump type for low pressure liquid chromatography in these types of applications. With these pumps, one of the primary advantages is that the only wetted material is the tubing. And it's generally or oftentimes the same tubing that's used elsewhere in the system. And this limits the number of materials that the solvent or fluid has to contact. It limits the number of materials that have to be validated, tested, or of any concern overall. And then lysis buffer addition breaks down the cell structures, allowing for the extraction of the target molecule. And Masterflex pumps, peristaltic pumps in general, are able to provide the accuracy to meter the exact amount of buffer needed to deliver the highest product yield. And as we reviewed earlier, as Greg was referring to earlier, cross-flow filtration requires pumps that are able to provide the flow velocity coupled with the appropriate pressure to sweep and clean those membranes and permeate through the filter. And final fill, which is the last step, is where the pump might be needed to dispense the purified protein, nucleic acid, or other molecule into the final storage vessel. Next slide. So let's quickly summarize where these pumps can help to improve the productivity of the cell culture process overall. During preparation, we saw or we discussed that Masterflex pumps are able to provide the flow accuracy necessary to rehydrate or dilute the media with customer in-house blends to meet the exacting criteria needed for cell growth, to meet the required concentration, the required dilution level. In the growth phase, accurate nutrient feed, pH control, oxygen demand control, recirculation or resuspension of cells, and sample dosing are all sub-processes that can be improved and optimized using peristaltic pumps. And then when harvesting, centrifuges and filters require pumps with flow rate control, with the appropriate flow velocity and the appropriate pressure capability to efficiently separate the cell suspension from the growth media. And finally, during purification, pumps provide the pressure capability required for accurate filtration and the accuracy needed for lysis reactions and extraction via chromatography and via fraction collection. And back to Mike.
Yeah, thanks, Phil. So let's continue our conversation with another poll question. Please select those pieces of equipment that you or your customers use in your process. Again, we'll pause for about 10 seconds to allow you to make your picks, and then I'll report the results. Okay, the results are coming in. Okay. Boy, really a wide array here, but the number one actually at 63% were bioreactors, but centrifuges was close behind at about 45%. So a nice spectrum across the board. Cell growth factory, let's see, 8% was the lowest. So again, thank you very much for your input, and I'll turn it back over to Phil.
Thanks, Mike. And next slide. So going into a little bit more depth in terms of what the advantage are of peristaltic pump technology and Masterflex and Ismatec pumps specifically. So, and there are a number of those that apply specifically to cell culture workflows. So first of all, the pumps need to be application appropriate, and Masterflex and Ismatec pumps and tubing have proven to be very, very well suited for these applications with our easy load style pump heads and pump drives that deliver very accurate speed control over a very wide range. our broad range of tubing materials, and I think we have over 22 different formulations, allow for a broad range of chemical or fluid compatibility. And also, as I referred to earlier, matching up with other materials that might be used in your process to minimize the different materials that need to be maintained or validated. And closely coupled to this are various low contamination and high purity tubing formulations that we offer, particularly looking at our BioPharm silicone, which is a platinum cured silicone product, or even some of the Stay Pure products from Gore that meet those requirements. And additional formulations besides, and it really, again, depends on your different requirements and application specifics and other materials that you might be using currently. And peristaltic pumps, in addition, are self-priming. So what that means is that there are no special considerations needed when setting up tubing, plumbing configurations, or fluid paths, where a type of pump that would require priming might require some very specific modifications to that fluid path and where the pump is in relation to other components. Masterflex and Ismatec pumps offer a flow range from microliters per minute all the way up to over 40 liters per minute, and that's a range that's broad enough to handle almost every cell culture process. And if you have concerns around scale up, that's another significant value of the Masterflex family of pumps, is that wide range of flow that we offer. And our pump drives, our range of tubing sizes, and again our easy loading pump heads also provide the volumetric efficiencies needed to accurately meter the reagents and chemicals used to control the cell culture process, and also in some larger scale fill and finish type applications. And lastly, or not lastly, but finally on this slide, the process needs viable cells to make it through to the harvest and separation phase, viable cells and viable molecules. And Masterflex pumps and peristaltic pumps are inherently low shear, meaning they're very gentle on the fluid that's being pumped. So it's another way to ensure, to maintain, to optimize cell vitality and the structural integrity of those molecules. Specifically, with a peristaltic pump run at relatively low speed, that is a way to further ensure that low shear functionality and that cell vitality and molecular integrity, as I mentioned. Next slide. So as we compare, the pump performance within that portfolio of pumps that we offer, we kind of break them down into a couple of different ranges, if you will. And the first one of those is the microflow or microscale. And these pumps are really ideally suited for research size, micro and smaller scale bioreactors. They have a flow range suitable for most addition applications, as I referred to, metering reagents or acid base to maintain pH, or even nutrient feed in those applications. And that low flow range is also particularly well suited for some of the newer micro reactors coming on the market. Things are getting smaller in scale in many cases, and we have pumps that are ready to serve those applications. And integration and control. These pumps offer remote operability via different types of control signals and communication protocols. And that allows for easy integration into automated systems, and where there are, bioreactor controllers that are automated systems for maintaining that optimal environment that I mentioned a little bit earlier. And then moving into what we're calling the general purpose pumps here. These are pumps that offer very simple flow control, not a lot of bells and whistles, really easy to operate, just really well suited for the small to larger production scale bioreactors. Very useful in terms of additions and recirculation specifically. Really best suited to continuous pumping uses. Where, or you might be just doing a general transfer from one container to another. And the last category here we're calling pump fill and dispense, or digital dispensing type pumps. Again, these are suitable for small to larger scale production reactors, useful for all filling, dosing, and volumetric dispensing needs, where you're metering a very specific volume of fluid in a defined period of time. And these pumps can be calibrated to ensure optimal accuracy, to ensure that you're getting exactly what you need when you need it. And again, these pumps offer that remote operability via different types of control signals and COM protocols. So for applications where they are being integrated into a larger system, where we have pumps that are ready to serve those needs. And back to Greg.
So one of the most important selections that can be made for your biofarm process is the tubing that's being used in it, and we're going to talk about that over the next couple slides here. Masterflex offers more than 22 different formulations to choose from. This is a broad range of chemical resistance, and selecting the correct material can be confusing for your cell culture application. In general, overall, the tubing materials used in this industry must pass USP Class 6 and European Pharmacopoeia testing criteria. Typically, this is a minimum certification it must have. Some companies require additional compliance testing for leachables and extractables. The most popular material used is silicone-based. The Biofarm Plus silicone, a platinum material, is one of the best to use in bioprocessing applications. It has very low spallation, very smooth surfaces to prevent cell adherence. Additionally, it has a very short break-in period, and it holds its shape retention better than other materials. This means improved pumping accuracy. For longer campaigns where tube life is a concern, we recommend the thermoplastic elastomer formulations, especially the Pharmed BPT and the Puriflex materials. Filtration processes where higher pressures are needed, Gore Stay Pure materials are preferred, along with some of the co-extruded materials that we offer. For single-use applications, we recommend our Puriflex formulation, which is ideal for use with cell culture bags, as it is both weldable and sealable. Mike?
Yep. Thanks, Greg. I'm going to take just a moment to touch on some tools that are used to monitor and control these workflows to maximize process quality and productivity. Our core offering consists of 4 product families that provide a variety of flow, pressure, and temperature sensors to meet your particular need. Our Masterflex single-use sensors provide high-accuracy flow rate measurements for low-viscosity fluids using flexible, modular sensors with low initial setup and operating costs. Our Masterflex ultrasonic flow sensors and controller offers a non-invasive and therefore reusable flow measurement solution that includes the ability to automatically control pump speed to maintain a user-defined flow rate regardless of changes that may occur in your flow path over time, like filter loading or tubing break-in, that kind of thing. The Levitronic single-use offering includes disposable ultrasonic sensors that measure flow rates from 30 milliliters per minute up to 100 liters per minute and come with sanitary fitting connectivity. It also includes a high-efficiency centrifugal pumps that offer high flow rates with very small footprints and also include disposable single-use chambers. Finally, our Pentatech inline pressure and temperature sensors, along with a variety of compatible monitors, allows you to collect, analyze, and control your processes while also providing some overpressure protection. So now we'll go to our final poll question, and that is, what are the top 3 criteria most important to you in optimizing your cell culture process? So if you could just take a few seconds here to give us what your top 3 are, I'll go ahead and report the results. And the answers are coming in. Okay, for our top 3, the number 1, non-shearing pumping action at 55%, followed by low contamination at 45%, and third, biocompatibility of tubing at 35%. So those are the top 3 criteria. So thank you very much for that input. And now I'll turn it over to Greg to summarize.
As a final summary, there are 3 benefits that peristaltic pumps bring to the biofarm process fluid handling needs. First, application suitability. The pump media contacts only materials that provide high purity and have been tested and certified to assure minimal contamination and increased purity. The technology is inherently low shear as there are no sliding surfaces that induce shear to the flow stream. If shear is an issue, utilization of pump design for even lower shear are available, such as our Cytoflow pumps. Second, efficiency. To improve filtration process and increase the filtration cycle, use of tubing and pumps higher pressure capability will extend these cycles and help improve the yield. Then last, operational improvements. Use of pump technologies that offers easy tubing exchanges will increase your operating time by reducing any downtime. And then finally, proper selection of tubing materials will ensure the proper life that's needed for improving your operations. I want to thank you for your time today. And with this, I'll turn it back to Joe to take us through any questions.
Yeah, thanks a lot for that presentation. I really enjoyed it. So yeah, there's been questions coming in. So I'll just start with the very first one we had here. So for the upstream cell culture process, low shear pumps are recommended. Are there any types of peristaltic pumps that cause less shear than the centrifugal or diaphragm pumps?
I can take that one, Joe, if you like.
Yep, by all means.
So yeah, thanks for the question. I think we touched on this a little bit, both on one of the slides that I referred to and also Greg's summary. But peristaltic pumps are inherently low shear, just because of the mechanism that they use. The fact that you're propelling, the fluid, whatever it happens to be, cell suspension or molecular suspension, through a piece of tubing. So there's no impeller, there's no gears, there's nothing that's mechanically impacting the fluid directly. And with that low shear, that inherent low shear nature of the peristaltics, there are ways to optimize, cell vitality, as it were, even more optimally. And Greg referred to what we call our Cytoflow pumps, and we have Cytoflow pumps in our LS and IP range. And the Cytoflow pumps rely on a unique convex roller that minimizes the impact force as the rollers are moving over the tubing. It minimizes the impact force on any of the cells or molecules that are moving through that tubing. And we have a white paper that shows, the data behind the testing that led us to qualify those particular pumps, that style of pumps, as the best among the Masterflex range for low shear pumping. But one other point I referred to earlier was that just generally running the pumps at relatively low speed is another way to ensure cell vitality and minimize shear. But we also have within the Masterflex family, Masterflex Drive coupled with a Quattroflow style quaternary diaphragm pump, which is also another means of minimizing shear at slightly higher pressure. So hopefully that answers your question. But generally, to summarize, peristaltics are inherently low shear, but we do have products within the portfolio that optimize that to an even greater degree. So again, thanks for the question.
That was a really good answer. Excuse me. Thanks, Phil. The next question, would you recommend peristaltic pumps for a long-term perfusion culture with high cross-flow rates that go over 60 days?
So I could take that one. Yes, there's specific combinations of pump and tubing that can help improve the life needed, and particularly using a thermoplastic tubing will extend to those that type of life needed and operate at the higher pressures in some cases that are needed as well. So a combination of going to a larger size tubing, reducing speed, and selection of thermoplastic materials will get you to the results you'll need.
Yeah, brilliant. Thanks, Greg. Thank you for that. Another question, can you comment on gas permeability as it relates to tubing material of construction? It might be relates to tubing material construction. I think
Yeah, sure. Yes, the tubing, and if it's a matter of scaling them or putting them in order, typically the thermoplastic materials have lower gas permeability characteristics, followed by the silicone being having a little bit more gas permeability than the thermoplastic materials.
Okay, thanks, Greg. I've got a question here. I think it's going to be from Mike. Can I use Masterflex ultrasonic sensors and controllers to improve dosing accuracy?
Yes, actually, great question. The controller that works with the ultrasonic sensors does have a dispense mode. It has a continuous mode to control the flow rates, as I mentioned, but it also has a dispense mode where you can actually do dosing if you do it in let's say discrete amounts, that kind of thing. If you want to do dosing over time at a certain rate, then you'd be more in the continuous mode. But it does have the ability to control pump RPM so that you can maintain that constant flow rate if you're trying to dose in a continuous fashion. So it does an excellent job of that. It also collects the data, its flow rates in a onboard memory, so that if you want to download it later for analysis, that kind of thing, then you have that also as information you can tap into. So it really is not only a process improvement, but also you can use it to analyze and improve your process over time. So hopefully that's helpful for you.
Yeah, it's a really good bit of kit, isn't it? Another question that came in. Someone's saying that they use C-Flex and silicon tubing today in different areas of production, but is there a tubing available that is suitable for both pumping, welding, sealing? Looking for a tubing size of 10 by 16 mil.
So yes, we have a newer formulation. It's called Puriflex that is both weldable and sealable, and provides very good low contamination, pumping characteristics, and longer life as well. It is a thermoplastic elastomer, and so it falls in that category of providing the longer life. So I would recommend probably switching over to that material if you're looking for those types of characteristics.
Excellent. Thanks for the advice, Greg. Mike, this is another flow controller question. So what does the flow controller do that the pump cannot achieve on its own?
Another great question. The controller, it makes it a more of an automated process. Typically, when someone sets up a pump, let's say in their flow stream, they set it at a certain RPM that when they do the calibration should reflect the flow rate that they're really desiring. But over time, depending on what the process is, let's say it's a filtration process, the actual flow rate at a constant pump RPM may actually decrease as filter loading occurs or something along that line, or as tubing characteristics change over time, which they have a tendency to do. So if you're just controlling purely at RPM rate of a pump, the actual flow going through the system is actually changing and perhaps declining, let's say. What happens when you use the controller with the ultrasonic sensor is the sensor will actually tell the controller what the flow rate is in fact, and the controller has a touch screen where you can say, I want to maintain a certain flow rate, let's say 100 milliliters per minute, let's say. And if in fact, because of those changes in the system, whether it be tubing characteristics or filtration or whatever, if that flow rate starts to decrease at the given RPM with a pump, then the controller will communicate automatically with the pump and say, hey, we need to speed up to maintain that flow rate that's set. And it will speed up then to maintain that flow rate. So that's the difference. And for folks who perhaps have to periodically calibrate or recalibrate their pump RPM in order to maintain a certain flow rate that they're trying to keep, this eliminates the need to have to do that. It automatically adjusts it so you can have a continuous process. So hope that helps.
Brilliant answer. Thanks, Mike. Phil, I've got a question regarding the Masterflex Live. So someone's saying they've already got a few Masterflex drives, but they want to know, can the Masterflex Live capability be added to their existing pumps?
Thanks, Joe. We didn't really talk at length about what Masterflex Live is all about. So let me give a little bit of background for those on the call who may not be familiar. But I did refer to different ways of communicating with the pumps, different ways that pumps can be controlled versus via remote signaling capability. And we have several of those. We have a legacy analog signal where you can control the pump via a voltage or current signal. We have Ethernet IP capable pumps that can be integrated into Ethernet IP networks. We have Profibus capable pumps that can be integrated into Profibus networks. And we also have what we call Masterflex Live. And Masterflex Live is a cloud-enabled monitoring and control app, if you will, that can be accessed via a PC or any mobile device, iOS or Android, whatever the case may be. And that Masterflex Live functionality can be used, as I mentioned, to both monitor and control the pumps. And when I say monitor, meaning, yes, the pump is running. Yes, the pump is running at the speed I want it to be running. And you can set up notifications, where you can be notified via text, via email, via push notification. If anything changes, if the pump should automatically shut down, or somebody turns off the power, or whatever the case may be. And that's one of the main advantages that really seems to resonate with folks out there, is that ability to be notified immediately what exactly is going on with the system. So that's really what Masterflex Live is all about. In a very brief discussion, if anybody has any further interest in it, please reach out to us. But those are pumps that do have very specific hardware in them. So it's not something that can be retroactively updated to legacy products that you may have. But we have Masterflex capable pumps throughout the LS and IP pump ranges. So again, you get that variability in terms of flow and control requirements for specific applications with the different options we have for Masterflex Live. So that's the answer to that question, I hope.
Yeah, brilliant. Thanks, Phil. There's also all the whole remote connections and stuff, isn't it, with the whole COVID situation, and being able to control
Right.
it from remote places is actually really handy, isn't it?
Mm-hmm.
Okay, so is there another question that's come in? Is there any inherent issues with running single head versus dual heads?
Could you repeat that? Sorry.
Yeah, that's okay. Is there any inherent issues with running single head versus dual heads?
No, I wouldn't say there's any inherent issues. I mean, just something you need to be mindful of in terms of, the flow range you're looking for. But I think, again, to back up a little bit, with the Masterflex Peristaltic pumps, you're able to stack multiple heads on a single drive. So where you might have seen several images throughout the presentation where you saw one pump head mounted on the front of a drive, imagine where you might have 2, 3, or even 4 pump heads mounted in sequence on the front of that drive. And what that enables you to do, among other things, is to dramatically increase the flow rate you can get out of that drive. And oftentimes, one of the other reasons that folks stack pump heads is if you stack the pump heads, the rotors and rollers within those pump heads are slightly offset between 2 heads. And by coupling the output with those 2 pump heads by using a double Y type configuration fitting, you're able to dramatically reduce the output pulse, or the pulsation in the output flow from those pumps. So there's a variety of reasons people do stack pump heads. again, simply to increase flow or also to reduce pulsation. And folks will also do that in dispensing or filling type applications where they're really looking to optimize flow accuracy. But again, just to be cognizant of the fact that you are going to be getting twice the flow rate that you would get with a single head and a single piece of tubing.
I just find the whole thing fascinating, the whole stacking heads on and getting that performance. It's just really interesting. Thank you, Phil. There's a question here regarding pumping volumes from different heights. So how accurate is the pump power to push liquid up above a reactor? Just for example, if the pump's on the ground and it needs to travel, say, about 10 feet to reach the port.
So I can answer that. So if you think about it, and we're pumping primarily very low or lower viscosity fluids primarily. So a 10-foot lift for a pump translates very roughly to about five pounds of pressure from the level of the pump to up above the reactor. So it's very well within the capability of the peristaltic pump to not only lift it from below the pump there, but to push it up to above the top of the reactors. The conversion factor there is if you're looking at feet of lift or pressure, it's about 2.3 feet is equivalent to 1 psi. So for every roughly 2.5 feet, you generate that tubing will generate one psi of pressure, and that's with a water viscosity type solution. As your viscosity goes up, some of your friction increases, and you have to take in some other things, but generally we're talking 95% of these applications being a lower viscosity type of material. And if you need to reduce pressure while your lift doesn't change, but if you're pumping a viscous fluid to get it to flow easier, increasing that diameter of the tubing that you're using will reduce the friction of that viscous fluid in a system as well.
Okay, so to every 2.5 feet, 1 psi is added. Did I understand that correctly?
Yeah, that's correct. I muted my phone before. Yeah.
No, that's okay. Just out of interest then, what's the highest it can travel? What's the furthest we can push liquid up?
Well, okay, so just pushing liquid, this is on the discharge side, so every 2.5 feet equals about 1 psi, and generally for most of our applications, peristaltic pumps ranges in the range of 20 to 30 psi on the maximum side. So if you're at 20 feet or 20 psi, you can lift at 30 feet. If you're at 40 psi, 50, 55 feet of vertical push you can get out of it.
That is impressive. That's very impressive. Thank you, Greg. That's a very enlightening answer. Mike, how do I know which size flow meter fits best for me if two of them meet my flow range?
Yeah, there's so many different options, and you take the different kinds of liquids in play, and everything else. What I would typically recommend is getting in contact with our applications team. You can call into our help line, and they will actually identify what the best match of fitting would be for the flow rates and the application that you're actually operating under. They do a fantastic job of marrying up the right solution with the application. So that's what I would recommend, is get in touch with them, and they'll make sure that not only do they have the right fitting size for what you're trying to do in the flow rate, but also it's be chemically compatible, because that's usually a major concern too. So they can step you through all of that. That would be my recommendation.
Okay, I think the single-use fan club are in because someone else has asked, what are the sterility options for the single-use sensors?
Yeah, there are a variety. They typically come packaged in clean room type of situations at the very minimum, but they also can be gamma treated. That's also an option that sometimes folks like to exercise. You just have to make sure that that you go with a PVDF type of material versus the PFA, let's say. And again, the applications team members can just walk you right through that. But those are typically the ones that are that. Oh, and they can be also autoclave. That's another option for autoclaving in advance. So those are the options that typically folks will exercise.
Okay, brilliant. Thank you. Oh, and there's another one here. Can the ultrasonic sensor be used with opaque tubing?
Yes, and this is another area where there's a lot of flexibility. The ultrasonics do not have to be used with clear tubing. They can be used with opaque types and often with different types of braiding. It's just that when it's metallic braiding, that's typically an area where they might have some issues with reflecting off of the braiding. But if you have a specific application and you're wanting to know if the ultrasonics will work with it, then again, this is a conversation ultimately we can have through our applications team just to make sure that it will meet what you're trying to accomplish with your tubing types. But it's very forgiving and will work on all sorts of tubing, including opaque type.
Okay, brilliant. Thanks, Mike. Phil, just back on the live line of questions. Someone asked about the regulatory requirements. So does the Masterflex Live meet or adhere to regulatory requirements and compliance? Data, I guess, data compliance.
Yeah, thanks, Joe. Yeah, good question, and that could mean a couple of different things. But with respect to Masterflex Live by itself, there is there's a basic level which gives you all the functionality I talked about earlier, where you get the ability to monitor, control the pumps. There's a premium or subscription level that we have available that gives you data control and data access. And by data access, I mean you're able to access the full operational history of that pump, including detail down to the level of detail of who did what and when. Because in order to access the Masterflex Live functionality, you have to log in with a username and a password, and so the system knows who is logged in and who is controlling the pump. So that level of data control, of data retrieval, does confer 21 CFR Part 11 or EU Annex 11 compliance on the subscription level of the Masterflex Live functionality. Beyond that, the pumps themselves meet regulatory compliance such as UL and CE requirements, if that's what the question was referring to. But I think it had more to do with that data control and data retrieval aspect.
Yeah, I think it was more to do with the 21 CFR Part 11. Yeah, thanks, Phil. Someone's asked, how can I learn more about the services offered by Masterflex in the area of process design and component specification / selection?
Well, I think Greg mentioned this earlier, but certainly work with and communicate with our technical support team and our commercial teams, because those folks are on the front line, as Greg said, and they're equipped to answer with those types of questions. And if you're referring to a need for tubing or different types of assemblies, they can certainly guide you through that process, because they know the process steps and the ins and outs, and they can answer those types of questions. So again, I would just encourage you to to reach out to our tech support team and our commercial teams respectively.
Okay, cheers. Thanks, Phil. It's good advice. Mike, on the clamp, the ultrasonic, the clamp, do they need regulatory approvals?
Actually, the ultrasonic clamp-on is a wonderful option for those that are trying to avoid a lot of cleaning requirements and those types of regulatory requirements. The sensor itself connects around and snaps around on the outside of the tubing, and so it never comes in contact with the working fluid. So a lot of the regulatory requirements that cover tubing, let's say, or fittings, don't apply to the ultrasonic sensor. And in addition to that value, the fact that it doesn't come in contact with a working fluid means that you can use it over and over again. It's not necessary that it be disposed of. And so it's a great way to make your regulatory life a lot simpler.
Right, you are. Okay, that. Thank you for that. And is there any software for the flow pressure sensors? What you said that the ones that produce a log of your process, documenting changes in flow and pressure.
Yes, and well, I think the reference I made was specifically to the ultrasonic controller, which is the actual controller itself, the box. It has an SD card that you can collect the flow rate data over time, and I think it's like 32 gigabytes. It's a significant amount of memory. The other different sensors, flow sensors in particular, don't log data, but the information that they collect can be sent to a PLC or some sort of process control where that data can be logged. And then on the pressure side, the Pentatech pressure sensors, again, those do not actually have internal memory to log data. However, they can through their the PMAT controller. It has software that will allow you to log data, the pressure data that gets collected over time too. So most of the sensors have the ability to ultimately collect data, but typically it's done in concert with other control elements that either the user has, or like I said, the ultrasonic controller has its own internal, and the Pentatech will have a software that allows you to easily log with an external computer from those products.
Brilliant. Thanks for that, Mike. That's a really good answer. Just scouring through some of the questions and comments. Is a subscription needed for the Masterflex Live? And if so, how much does it cost? Phil, I think that's one for you, sir.
Having a technical issue here. I think I touched on this a couple minutes ago, but the basic functionality of Masterflex Live does not require a subscription fee. It's again that includes the ability to control and monitor the pumps via either a PC or tablet or phone, whatever remote device you might want to use, or mobile device, I should say. The subscription level includes that data access and that ability to download and analyze the operational data history. And it really depends on where you're located in terms of what the subscription fee is. But I think it's roughly around $200 US a year per device, and again, that's going to vary depending on where you are. And whether you opt to pay by the month or by the year, so it's variability, but that gives you a rough ballpark of what that subscription fee is.
Okay, thanks, Phil. We've probably got time for one or maybe two questions, depending how we answer. Someone's asked about tubing splits, and if there's any kind of monitoring system that detects if tubing is split or if they've got a leak. So sort of checking how can they tell if their tubing is split or if they have a leak from a remote location. So is there a way of remotely detecting, I guess is the best way of rewording that question, if tubing is split or has a leak?
Yeah, I can answer that question, and hopefully I got myself off mute successfully. And I think Greg might have mentioned this in an earlier slide, but we have pump drives in the LS and IP families, and now in the Reglo family, that have the ability to directly connect a leak detector, and those are the pumps that have the open head sensor capability specifically. And that leak detector can be placed directly underneath the pump head, or it can be placed elsewhere in the fluid path. So let's say, for example, you're running flow through a capsule filter or some other kind of filter, or you have a connection that you're a little bit concerned about for whatever reason. And you can place that leak detector where you think there might be a leak that develops in the fluid path. And the instant it detects any fluid, and it's by a conductive method, it will automatically shut down the pump. So the pump will immediately stop pumping, so preventing any further spill or leakage of fluid in the system or in the fluid path. And that leak detection is also able to be detected via the Masterflex Live app. So if you have a leak detector set up on your Masterflex Live enabled drive, as soon as that detector is triggered and it shuts down the pump, you'll receive a notification, again, either via email, text, or push, but that detector has been triggered, and so you'll be able to respond accordingly. So hopefully that addresses the connection. But yeah, we do have leak detection capability, and it's a relatively low-cost accessory that can be coupled with the pump drives.
Perfect. Phil, that is a great answer to a great question, and that is all we have time for. We've hit our limit. Thank you, presenters. That was a really informative presentation. I really appreciated that. Thank you, everyone, for joining us today and for hanging around for the questions and answers. Like I said before, there was a short survey. Please just take 30 seconds just to fill out some of the questions in there. There is emails going out as I speak with links to our scientific expert series of on-demand previous webinars, so please have a look at those. There are some other Masterflex biopharma presentations in there as well. And please stay safe. And until our next webinar in 3 weeks' time, November the 19th, I believe. Until then, stay safe, and I hope to see you all again soon. Thank you so much.
Thank you.